We will present an article entitled Evaluation of Carbon Emission Level in UMN Library from the Use of Artificial Lighting. For the background, buildings contribute to around 34% of global energy use and 37% of greenhouse gas emissions, with artificial lighting accounting for 20 to 45% energy used in this sector. The UMN Library, one of the largest spaces in Building B, requires sufficient daylight and artificial lighting to support reading and studying activities. For problems, library uses enormous luminaires to support reading and study. However, these lighting systems use a lot of energy and produce carbon emissions. For the research aims, examine the potential advantage of artificial lighting optimization in the UMN library, with a particular focus on its effects on energy consumption and carbon dioxide emissions. For literature review, this research conducted a similar method from the previous researchers. DIALux Evo will be the main equipment used in this research as the building lighting simulation software, while those studies remain narrow in focus, dealing only with energy consumption and saving. This research will further study the impact and correlation of energy consumption on carbon emissions on UMN Library as its research object.
Here are the methods that we use for this research. The first one being the collecting data. We collected data regarding the site plan of the library, and then also the data regarding energy consumption, the lighting system specifications, the occupants, and then their operational hours. After the data is collected, we begin our simulation using DIALux for both conditions. The first one being the actual current conditions, and then the second one being the ideal conditions. After both simulations are done, we begin our analysis, which we will calculate the carbon dioxide emission, and also will include our recommendation in the form of the ideal condition simulation. These are the lighting types, the types of lighting system that we used in our simulation. And then this is also the standard that we use. The standard that is used is based on SNA 6197 in the year of 2020 regarding energy conservation on lighting systems, which it mentioned that the standard for libraries in educational institutions is at 350 lux.
The actual condition simulation began with making the 2D and 3D model of the library based on the site plan and direct observation. This is the 2D model of the first floor and the second floor of the library. And here is the 3D model of the library. And here is the lighting distribution for the first floor and the second floor. As you can see, the color is indicated the number of lux, and based on this color, we can conclude that the library fulfilled the standard of 350 lux. And here is the estimated annual energy demand and cost for the buildings and for each floor. And here is the energy consumption and CO2 emission per hour. The energy consumption per hour is around 12 kilowatt hour, and the CO2 emission per hour is 10.42 kilogram CO2.
For the ideal conditions, there are some changes that have been made. We decided to use fewer luminaires and use higher reflective factor material for the bookshelves. For the site plan or the model, we still use the same as the actual conditions. This is the ideal state's results of light intensity for the first floor. All the reading areas still fulfill the demand. And the standards for library, which is 350 lux. Same goes for the second floor. The reading areas still fulfill the needs based on SNE 6197 on the year 2020. The results show the estimated energy demand is about 15 to 22,000 kilowatt hour per area and will produce around 13 to 19,000 kilogram of carbon dioxide per area. These are the calculations for energy consumption per hour and carbon dioxide emission per hour. And these are the comparison between actual and ideal conditions for the energy consumption. There is a decrease of number of energy consumptions, which is 23.3% on the number of 2.8 kilowatt hour per hour. For the carbon dioxide emissions, there's also the decrease of number, which is 23.5% on the number of 2.45 kilogram carbon dioxide per hour.
So there are 3 points that will conclude our research. The first one being the current condition of the lighting system in the library that uses 3 types of light. And through simulation, we found out that the library has already fulfilled and exceeded the comfort level that is based on the standard that we used. Second point being the optimization that we did, which is the ideal condition simulation that used the same model, while also reducing the number of luminaires that we used and also changing the material for the furniture. And we found out that even though the luminaires are fewer than the actual condition, it still meets the lighting standard. The third and the last point is that the ideal conditions showed a decrease than the actual condition for the annual energy consumption that is by 23.3%, and then for the carbon dioxide emissions by 23.5%. This decrease would be able to help in slowing the effects of global warming and climate change, as a decreasing energy demand would also reduce energy generation that affects the rate of carbon emission.
Here are the references cited in our research article. That concludes our group presentation. Thank you for the attention.